Hello everyone and welcome to my YouTube channel. Today is day 10 of Kaggle's 30 days of machine learning challenge, and today we are going to learn about underfitting and overfitting, and we are also going to play around with random forest. What are random forests? It's another type of machine learning model. And if you want to learn how random forests work, I published a video right before this one, so you can go and take a look at that. Today in this video, I'm going to be just going to do a walkthrough of the tutorial from Kaggle. So, underfitting and overfitting, you need to understand these terms to make your model more accurate, more generalizable. So, when we saw that in the previous video, we saw that we built some decision trees and they performed so well on the training set, but they didn't perform very well on the validation set. So my training error was just around 500, my validation error was around 25,000 or 250,000, something like that. But so the difference was huge. So I have in the lecture when I was discussing what are decision trees and how decision trees work, I have already mentioned this term overfitting and how it can be prevented. So if you have a bunch of features and you keep building the tree, you keep going deep, you keep splitting each node, in the end, you will reach a point where the tree is going to predict perfectly for the training data. And when that happens, it's generally called overfitting. So the concept of underfitting and overfitting can be easily understood by a very simple example. So let's say I have a dataset in which I have a feature X and I have the target variable Y. So now I have only one feature and one target. So I can plot them. So I will just plot them here. So like I have 1 point here, 1 point here. So let's say I have something like this. So these points are following a pattern. As you can see, the points which don't follow a pattern will be outliers. So I have outliers, I have some outliers like this. And now your job is to come up with a function y equal to fx. Y equal to fx. So one of the easiest thing to do this will be to just create a simple line and say this is my function and that should capture all the properties of this particular data set that I have. So this function is your machine learning model, right? So you have this function, you supply value of x and you get some value of y. So now here what's happening here is these points, you can calculate error by subtracting the value of these points from what you get, and you will notice that this function is not able to capture all the training data. So, and the error in the training data is very high. This case is known as underfitting. So when the model is not able to capture the training data itself and the error in the training data is very high, it's called underfitting. Now we move to the next one, something called overfitting. So now in overfitting, what happens is you come up with some function that captures everything. So it goes like this. So something like this. But yeah, you understand what's happening here, right? So it goes like this and it captures all the points. So now if I give you a new point, it's going to have very high error. So a new point from the test dataset or validation dataset, because it has perfectly learned all the samples that you have inside your training set, and it's not going to perform well on anything that is outside the training set. So it's not going to, this kind of model is not going to generalize. And this is called overfitting. Now, underfitting and overfitting, both of them are going to give you a very hard time, and both of them are not very good for the model. So you will try to come up with a function like this that maybe captures most of the point, And there are some points which are left, but it doesn't matter. It has captured the essence of your data. And this kind of model will generalize. So that's what is shown in today's lecture here. And this is what I also showed you in the decision tree lecture. So like when you're building a decision tree, let's say you are building a decision tree and this is your, on the x-axis I have error, and on the y-axis I have, sorry, on the x-axis I don't have error, on the x-axis I have depth. So like, let's say depth of the tree, and on the y-axis I have error. So error should be low. And you have your training error. So if you keep on increasing the depth, your training error is going to look like this, and it will approach to 0 if you keep on increasing the depth. And now your validation error is going to, so let's say you have split your data into training and validation sets. So that's the first step that you should do when solving any machine learning problem. And your validation error will look something like this. So now what's happening here, okay, let me make it a little bit more deeper. Okay, so now what's happening here is, this is your training error, and this is your validation error. So your model, as you keep on increasing the depth, it will understand the training data perfectly, and it won't be able to generalize on anything that's outside the training data, that is a validation set. So your validation error will keep increasing because the model is learning your training data. It's not finding patterns. It's only finding patterns to solve the training data. So here it's your sweet spot, and this side is overfitting, and this is underfitting. So what you do is, the first step in machine learning is to divide your data into two parts: training and validation. And when you have that, you train your model on the training data. So let's say I used max depth, the argument max depth in my decision tree classifier from scikit-learn, and I used tree. Okay, I train the model and I calculate my validation score. So it can be any metric. It can be mean absolute error, mean squared error. It can be classification accuracy. So anything that you want to use that fits your data. And then I did max underscore depth equal to 5, 7, 9, 10, and I plot this. So for each of them, what my training error is and what my validation error is. And when my validation error starts going up after going down, that's the point I should choose. So maybe it came at max depth equal to 7. And I say, okay, I will choose max depth equal to 7 to train my model. And that's the best model that you can get. So all you have to do is avoid underfitting, avoid overfitting to get the model, which is the most generalizable model. So I hope now you understand the terms overfitting and underfitting. And that's what is mentioned in this whole tutorial. So they also have given you this example. So what's happening here? You import a mean absolute error, which is a metric. You import decision tree regressor, and you create a new function called getMAE, which takes in training data, validation data, training labels and validation labels, and max leaf nodes, which is one of the arguments of decision tree. So instead of max depth, they have taken max leaf nodes. That's fine. You just have to make sure that you keep random state to a fixed value to make your model reproducible. So you fit the model on the training and validation set, you calculate the predictions for the validation set, and you calculate the mean absolute error, and you return the mean absolute error. So let's run this one, and we will also take a look at the next cell. So in the next cell, it's nothing but you have already seen, so I don't have to explain this. So you have a bunch of features, and here you are using train test split to split your training data into training and validation set. So this chunk of code comes from last day. So you can just take a look at that. But now what we do is we create a loop where it goes through a bunch of max leaf nodes. So let's add more values, 25, 50, 500, whatever. And it calculates a mean absolute error it trains a new model for each of this parameter, and it gives you the mean absolute error on the validation set. So let's try to train and see what the mean absolute error is. So it starts with 5, and my mean absolute error on the validation set is 347,000, which is quite high. As we increase the max leaf nodes, this error decreases, right? But in the end, you see that the error increased, and now it's stagnant. Maybe it's decreasing a little bit. So this is your sweet spot, 243,000. So now if you have to choose the parameter max leaf nodes for your decision tree regressor, you will choose 500 instead of whatever the default parameter is, or 5 or 10, or so. Rather than just guessing, you can just train a bunch of models on different parameter values and see where you get the least validation error. So now there is one more thing. Machine learning is very cool, right? So now you created your data from your you created training and validation data from a given data set. So here is your given data set. You created training and validation. Now you trained your data on the training data. So I hope you can see the screen. So you trained your model on the training data, and you found out the best parameters that give you the best score on a validation set. So now one can argue, isn't the model overfitting the validation set? Okay, so yeah, that's also possible. And that's why we also keep a separate test set, and we don't evaluate our model on that. So we say, if my validation data represents all the training samples perfectly, the model is probably going to work in the same way as it did on validation set on the separate test set. Okay, I hope it was useful. And now we move to the exercise. So yeah, here it says capturing spurious patterns that won't occur in the future, leading to less accurate predictions. This is called overfitting, and failure to capture relevant patterns, which again leads to less accurate predictions. So that's called underfitting, and we use validation data. Okay, let's see. Now we do a small exercise on optimizing the model that we had previously. So this cell I'm not going to explain because you have seen it in the previous lecture, and I've explained it there. So this is only setting it up. And get MAE function, now it's the same function from the tutorial. So it's trying to optimize max leaf node parameter of your decision tree regressor. So now here it says compare different tree sizes. So write a loop that tries the following values, and get the you call the get MAE function on each max leaf node values. So yeah, I don't know if I should do that, but let's try. Let's do it. So for candidate in max leaf nodes, so we can do something like this. For each of them, get MAE. So my MAE value, MAE of the candidate is candidate, and then I have train underscore x, val x, train y, and val y. So here everything is defined here. So we can just use it directly. And what can the best mean absolute error value be? So it can be MAE equal to the worst value can be infinite, right? Since it's absolute error, it cannot be negative infinity. Here, do we import numpy? No, we don't. So I will just import numpy here. Import numpy as np, and np.inf is the infinity value. So I said my best MAE is np.inf. Now I say if MAE is less than best underscore MAE, best underscore MAE is my current MAE value, and here instead of doing a best resize here, I will just write it here, and best resize, let's say I start with -1, and my best resize will be the current candidate. So one of these. Okay, I hope you understood. Max leaf nodes. Okay, so this is candidate max leaf nodes. Okay, I hope it was understandable. So we started with some weird best resize, and we put infinity as best MAE. So now we calculate MAE and then see if the MAE is less than the best MAE that we had. We exchange the values, and we change the best resize to the current candidate. Okay, so fit model using all the data. So final model. So now you know the best resize. So what you can do here, you can here let's take the same random state 2. So this best resize is also only for this random state if there's a lot of randomness. So now my best resize is best resize. So we didn't check actually what the value is. So we can just write it here. So the value was 100. And my final model will be trained on the full data. So we train on the full data, and that's it. So that's what you have to do in this exercise. I hope you understood everything, and now we can go to random forest. And in random forest, I'm not going to go through the tutorial today because I have already made a separate video for that. And if you want to understand random forests, that's the video that you should use. But I will go through the code. So we've run this code, and this is the same old code, splitting the Melbourne data into training and validation sets for our own training. And instead of importing, instead of doing from sklearn.tree, import decision tree classifier or decision tree regressor. Here for the regression problem that you have, you import from sklearn.ensemble, import random forest regressor. And when you do that, you can just use it in the same way as you did with decision tree regressor. So here I will try to, I'll train a model, and this gives me a MAE of 191,000. So now you saw that this is an improvement, because in the previous model, the decision tree regressor model we had an error of 250,000 on validation set. And why random forests work so well? Watch the other video. And now we go to the kernels, the exercise kernel for this one. So let's run this and see what we have to do. So we have to use a random forest regressor again. It's the same data, so I don't have to look at the data. You don't have to look at the data. You can just start coding. And here I can do random forest regressor. Regressor, and here it says you should use random state equal to 1. Okay, so now we have to fit the model. So we fit the model on the training dataset. So rf underscore model dot fit train underscore x train underscore y, and we calculate the mean absolute error. So first we see is mean absolute error imported. Okay, yeah, here it is. So we can just write mean absolute error val underscore, or was it valid? Val underscore y. Okay. But before that, we need to make prediction. So pred is equal to rf underscore model dot predict val underscore x and mean absolute error val y comma preds. Okay, so now this gives you 21,857. So that's all we have for today. I hope you liked the video, and I hope you do subscribe, tell your friends about it, and I will see you tomorrow for the last day of Intro to ML. And tomorrow you can get the certificate for that, and after that we will start with intermediate machine learning. So see you next time. Goodbye. Thank you very much.